Today we're going to talk about solving inequalities. So let's just talk about a couple basic ones here. Solving these and graphing them. So what I would do is I would treat it just like an equation in that I would just distribute. So I get negative 12w plus 3 is greater than negative 12w. I would subtract 3. So I get negative 12w equals negative 15. Whoops, not equals, greater than. I would divide by negative 12. Now you got to remember, when you're dividing by negative, you got to switch that sign. And I would reduce, let's see, what number goes into these. Looks like 3 will go into both of these, 5 and 4 times. And because there's two negatives, it would cancel. And now, when we write inequality solutions, what we normally like to do is we like to use solution sets. So I don't know if this is a review or not, but I'm going to include solution sets. So those are those little brackets, and I'd write W, and then you can either write a line or a colon right there. And this means all values or all real numbers W, or all values for W, such that W is less than 5/4. And then we'd go through and we'd graph. And I'm going to squeeze a graph in over here. Now, everyone will have different rules for graphing. I'm just going to do a real basic one here. If I put 5/4, remember if it's less than or greater than, it's an open circle. And then since it is less than, I'm going to shade in this direction. Okay, let's do one more. What about this one right here? You see it says 5/8 x minus 3/4 is less than or equal to 1/5. Well, I would go through and I would find a common denominator and do a fraction buster. So the common denominator between 8, 4, and 5, let's see here. It doesn't seem like it's going to be an easy one for us. So maybe what we'll do is, how about 40? I guess that would be easy enough. So let's multiply this entire left side by 40. And this right side by 40. So if I do that, I get 25x minus 30 is less than or equal to 8. So I'd add 30. 25x less than or equal to 38. Divide by 25. X is less than or equal to 1 and 13/25 if I want to write it as a mixed number. And if I write it solution sets, it would be all real numbers x such that. And again, if I were to graph it, 1 and 13/25, this time it's less than or equal to, so it's going to be a closed circle, and it's less than again, so I will switch or have my shading go to the left. Okay, so hopefully that's a lot of review right there for you. But what I would like to do here today is I want to talk about graphing multiple inequalities, or what we'll soon call compound inequalities. So let's take a look at what we have here. It says down here, graph and give the solution to x is greater than 3 and x is less than or equal to 15. Well, so in other words, I want to know what are the numbers that are bigger than 3 and less than 15. Now the word and is inclusive. It means both things have to be true. Okay, so I need a number that's bigger than 3 and at the same time it's less than 15. So in other words, I couldn't pick the number 30 because 30 is bigger than 3, but it's not less than or equal to 15. And the same thing with, I couldn't pick negative 7. Negative 7 is less than or equal to 15, but it's not bigger than 3. So I got to pick one that's, I have to have the numbers that are between those. So what I'm going to do is I'm going to write the number 3 here, and number 15 here. And it's going to be all the numbers in between here. So it's greater than, so we're not going to include 3. It's less than or equal to, so I am going to include 15, and I'm going to shade just like that. Now, on the other hand, we have a word like or. Or is all inclusive. It means that either situation will make us happy. Okay? So when it says x is less than or equal to negative 2 or x is greater than 5, okay, as long as you give me a number that's satisfies either this part or this part, I'm a happy person. So, as I look at this thing, I'm going to write negative 2 here. I'm going to write a 5 here. Greater than 5, less than or equal to negative 2. And there you go. Now, these first two are what I would call the traditional way that AND statements and OR statements look. ANDs usually are shaded in between, ORs usually are kind of going in an opposite direction. But that's not always the case. So for instance, if we get down here to the number 3, let's go ahead and graph number 3. So I'm going to graph, here's 1, here's 3, 1 is greater than, x is greater than 3. Alright, so you see in this case, we have kind of an odd situation. Before, we were looking at the stuff in between. But in this case, they're both going the same direction. Well, here's where you got to remember what I just said. I said that in an AND statement, both situations have to be true. So I need a number that's bigger than 1 and bigger than 3. So as I look at this graph, okay, where are all the numbers that are bigger than 1 and bigger than 3? Well, they're all in this region here. Okay, so this is what I like to call this first part is what I like to call an inefficient graph. It's not a great way to write your solution. So what you need to do is you need to rewrite your graph. So I'll just write it below here. And so since this is the part here that makes both of these true, and that's essentially at the number 3, okay, my real graph will look just like this. And my real solution to this would simply just be all values of x such that x is greater than 3. That would be the best way to describe this situation. So essentially this part is useless. Okay, it's repetitive information. We don't need it. So all the numbers that are bigger than 3 will satisfy both of those. Well, let's look at this one. So this one says x is less than 6. Here's 6. Less than is going to go this way. Here is negative 2. It goes that way. Alright, so here's another kind of odd situation here. We said up here is where the ORs normally are. Or they look like this situation most times. But this time they cross each other. Okay, so remember what I said. I said that ORs have to, any solution for an OR statement, okay, as long as it satisfies one or the other statements, I'm pretty happy. Well, as I look at this graph, okay, where are all the numbers that will satisfy one or the other? Well, all these will, okay, as well as all these going out that direction. So essentially, everything up here would satisfy either one or the other. There isn't a single number out there. You know, if you take a number anywhere on the number line, the number is 1, 2, 3, 4, 5, 6, or negative 2, negative 3, negative 4, negative 5. It'll either satisfy one or the other. It doesn't make a difference. So what is my actual solution to this? Well, it's all real numbers. Anything will work for us. Okay, let's try one more. Okay, what about this one? This one says x is greater than 4. X is greater than 1. Alright, so where are all the numbers that will make either one or the other true? Well, that is all of this section here. Okay. So my solution, or my graph, let's say, would be at 1 and bigger. So all real numbers x such that x is greater than 1. Now, let's kind of review a little bit here. As I'm looking at this, when I look at AND statements, we're always looking for parts of the graph that are overlapping, okay? Because the overlap is where it'll make both parts true. So like for instance here, okay, overlapping part was here, so that's what our graph was. Okay, versus down here with an or we include anything that's being shaded, we're going to put that in our answer. So that's why here you notice that this is the region that everything is being shaded, so we included it. Over here, we had things going in opposite directions, so everything being shaded in that case was everything. So that's why we made it all real numbers. Okay, so I hope that makes sense. Hopefully that helps out some of your understanding. But that's the basics of solving and graphing inequalities.